I don't think I've ever been more proud to be a materials engineering student, not just in general, but also at McMaster. I've been with the community for a long time. I entered the department as a second year undergrad in 2013. And ever since then, I've really seen the efforts and also the results of the department in their successful attempts to be an epicenter of excellence. The department has a span of expertise that is quite frankly unparalleled and really an amazing thing to be a part of.
Today, we're facing really massive sort of global scale problems, whether it's in manufacturing, transport, environment, energy systems. These problems, we historically have fixed them by over-engineering workaround solutions because we didn't have the materials required to solve the problems that we're looking at. But materials engineering, especially in the last 20 to 30 years, has exploded with research. And once we develop the solutions, once we make the lighter steels, once we make the more efficient energy sources, once we create carbon sequestration, once we make plastics and ceramics, these things that are reusable, plastics or ceramics, so good, so strong that they can replace other materials that are non-renewable, that are non-efficient.
We also have opportunities to work in electronic, nano-optical materials as well with bleeding edge tools. If you work for somebody like Dr. Botan, or you work with Dr. Maureen Lagos or Dr. Basim, or any of those people, you're in a top 10 class in the whole world, because not only are you using modeling and different kind of theoretical understandings of the way that material science works, but we have the actual tools to do the research. And oh, by the way, you get to be trained on those things if you're a part of those research groups. I see amazing things happening. There are grassroots movements for materials-focused clubs and teams. I see the computational material science students getting together, not only to do interesting things for themselves, but then also to share with the undergraduate and graduate community at large. I look at the Macsmiths that are a bladesmithing group. A couple years ago, it was a group of people that I went through my undergrad with, and they said, wouldn't it be cool if we could start making swords? And now we have a self-sustaining group of people who make swords and knives and analyze the metallurgy of that, and compete on a world scale,
In the 2019 TMS competition, we ended up placing third place overall. We were commended by our material characterization, but also our historical accuracy. The team also grants undergraduate experiences that cannot be compared to any other clubs. Not only do we get direct communication with industry and can learn a lot from them, but we also get hands-on lab experience that can't be seen anywhere else aside from graduate level work. We've seen how much we can push the McMaster name out and really get the school on the map in terms of materials engineering.
When you add in materials to the 1P13 projects, you stop taking things for granted, because you learn that there's not one kind of concrete, one kind of steel, one kind of copper wiring, and that's all you have to work with. You get to learn that there's different things that you can obtain in different ways that you can process those same materials to really figure out the best thing to do and make it the most cost effective or greener, like the most sustainable or the most efficient solution. And it's not necessarily the case that one of those comes at the expense of the others. I love my students. I don't know how else to say it. Our undergrads are incredibly inspiring. They make me excited to come into work or sit at my computer in my kitchen. They're curious, they're involved, they expect excellence of themselves, and they make me do my best every single day because I want to do right by them. And it's you guys versus the assignment or the concept or the problem, and it's never you guys versus each other. And you guys are competitive with yourselves. You want to be the best versions of yourselves, to be the best engineers you can be for the world that you're going to inherit. there's a lot of things that are wrong in the world, a lot, and a lot of things to be deeply troubled by. But every day I see students sacrificing so much of themselves to be the best people they can be, to do their work in the world. And I just think that's the most magical thing that I'm privileged to be a part of, and the thing I will miss the most.